going to go back to the start. So when you did your experiment and you calculated the resistance, voltage divided by current, hopefully you found that they were more or less the same. They probably were deviated a little bit, but I think it's probably about 6, 7, or 8 that the resistance should have been. And they should have been, all these values should have been about the same. Okay. So when you ended up plotting your graph, what you should have got was a straight line through the origin. Okay, if you did your scales properly, didn't miss out a bit of the scale. Or more or less straight line through the origin. Okay, so that means we've got a graph which is a straight line through the origin. Now, thinking back to maths times now, so this might be a little bit rusty. The equation of a straight line through the origin is y equals mx. We're all familiar with that, hopefully? Okay, good. So if we replace y and x with what's on the y-axis and what's on the x-axis, then we have voltage equals gradient times by the current. We already know that voltage is current times by resistance. Yep, so that resistance is the gradient. And those of you, I think, that actually calculated your gradient, you found that your gradient was about 6, 7, or 8. Okay, so you can find the gradient, that you can find the resistance of a resistor by plotting voltage against current and finding the gradient of the graph. It's a long way around, but you can do that. So then I asked you to think about the questions. So what does your graph tell you about the relationship between voltage across and current through the resistor? Cameron, I know you got this one. Yeah, as one goes up, the other goes up. Yep. The second one isn't really a question. For a relationship to be directly proportional, the graph must be a straight line, which also passes through the origin. So we have a directly proportional relationship. Okay, so as one goes up, the other goes up. But in a directly proportional relationship, that means if one goes up, if one doubles, the other doubles. If one triples, the other triples. So if the voltage across our resistor is doubled, what happens to the current flowing through it? And what happens if it's tripled? Anyone? Felix? Yeah, double or triple. So if the voltage is doubled, the current doubles. If the voltage is tripled, the current triples. Does the resistance change when the voltage across the resistor is changed? When you change the voltage or the current, did the resistance change much? It shouldn't have done. The resistance should have been about the same. It might have changed a little bit, but it should be constant, okay? What does the gradient, the steepness of the slope, tell you about the resistor used? We just said that. What does the gradient equal? Voltage over current or resistor? Yeah, resistance. Well, you know what I'm right, resistance. For some reason that's not working. I'll leave it as resi. Can you predict the graph that would be obtained for a resistor with a higher resistance? So if the gradient equals the resistance, if you have a higher resistance, you would have a higher gradient. Yeah. So you'd have a steeper line, basically. Steeper line. Right, so in conclusion, the resistance of the resistor remains, Jamie? Consistent, yeah, or constant? This is the first time I'm using this pen since I've got back, so it's obviously either run out of battery or something. Consistent. When the current flowing through it and the voltage across it changes. The shape of the graph tells us that the voltage across the resistor is, anyone? Thank you. Directly proportional to the current flowing through it. Okay, not quite finished, got a little bit over the page to fill in. If you haven't got your booklet, by the way, today, then you can go home and you can copy it. You can just look at the OneNote if you want. In maths, the equation for a straight line passing through the origin is y equals mx. In this case, v takes the place of y and I takes the place of x. So we end up with v equals m times I. We already know that R equals V over I, so if the resistance is equal to the gradient, then V equals I R. This relationship is known as Ohm's law, and Ohm's law states that the voltage across a fixed resistor at a constant temperature is directly proportional to the current flowing through it. So next lesson, whenever that is, we're going to be looking at a bulb rather than a resistor and seeing if it's the same thing. So yeah, you can pack away.